This question is about angles between radius vector and tangent to the polar curve. Or you can also write with the usual notation prove that tan phi is equal to r into d theta upon dr. Here phi is the angle between radius vector and the tangent at the point to the polar curve, that is r is equal to f into theta. Then tan phi is equal to r into d theta upon dr. So let's move on to the proof of this particular question. For that, we consider 2 points, that is if x comma y are Cartesian coordinates of the point P, then we have x is equal to r theta, that is x is equal to r cos theta and y is equal to r sin theta. So to do this, we draw the Cartesian plane where we have x-axis and y-axis. So this is the x-axis and this is y-axis, where we have two lines which make an angle phi. The angle between the x coordinate and the line here is theta, and this angle here is psi. This is the point P which we were talking about, that is the angle between the radius vector and the tangent. The coordinates of this P are r comma theta. So this is phi here, and this also will be phi because we have vertically opposite angles here. So using the differential equation, we write dy by dx is equal to the slope of the line P and m here, m on x-axis, so slope of pm. So from the figure here, we can see that for the slope pm, we can write dy by dx is equal to tan psi. So tan psi can also be written as theta plus phi, because psi being an exterior angle, it is always equal to the interior opposite angles. So here we write instead of tan psi as tan theta plus phi. So here we are using the formula for tan a plus b. We write it as tan a plus tan b upon 1 minus tan a into tan b. That is why we have written tan theta plus tan phi upon 1 minus tan theta upon tan phi. So this here we represent the equations here. So this being the equation, this being the equation 1, this being the equation 2, and here this has 3, this has 4th equation. from equation 1 we can write dx by d theta as minus r sin theta plus cos theta into dr by d theta, and we represent this as equation 5. So we are here, this is written by differentiating equation 1 with respect to theta, that is x when differentiated with respect to theta, we have dx by d theta is equal to minus r sin theta plus cos theta into dr by d theta. Similarly, we will differentiate the second equation in that is y is equal to r sin theta. When we differentiate y is equal to r sin theta, we have dy by d theta is equal to r cos theta plus sin theta into dr by d theta, and this we are representing as equation 6. As we need dy by dx, so we divide equation 5 and equation 6. So dy by d theta we have, and dx by d theta, where d theta gets cancelled here. So dy by d theta is nothing but r cos theta plus sin theta into dr by d theta upon dx by d theta we have r sin minus r sin theta plus cos theta dr by d theta. We are dividing here by cos theta into dr by d theta for both numerator as well as denominator. So when we are dividing it, we get dy by dx as r d theta by dr plus tan theta upon, similarly when we divide denominator by cos theta into dr by d theta, we get minus tan theta d theta upon dr plus 1. Here next we are comparing equation 4, and so this being equation 7, we are comparing equation 4 and equation 7. When we compare both the equations, we get tan phi is equal to r d theta by dr, or you can also write this as, because tan theta and cot theta are reciprocals of each other, so cot phi can be written as 1 upon r dr by d theta.